All right, let's look at the homework 14.7, problem number 9. We want to find the maximum volume of a rectangular box that is inscribed in a sphere of radius r. All right, so let's do that. All right, so I drew a picture. All right, so the equation of the sphere is going to be x squared plus y squared plus z squared is equal to r squared, right? So I'm going to just solve this equation for, let's say, z, right? So this is going to be, right, subtract x squared and y squared. We get z squared is equal to r squared minus x squared minus y squared, right? Then we can just take the square root of both sides. So we get the z is equal to square root of r squared minus x squared minus y squared. All right. Then let's try to find the volume of this box. All right, so let's say we take one vertex. So say the coordinates are x comma y comma z, which is sitting on the on this sphere, right? Then the volume of this a box can be written as, so volume is going to be equal to, all right, so if you look at the length, so if the coordinate, x coordinate is x here, so we have x up to the middle point, then you have x in the back. So actually the length of this side is going to be actually 2x, right? And the length of this side is going to be, because it's going from y to negative y, so you have a 2y, right? Then the height of the box is also 2y. So the volume of the box is simply 2x times 2y times 2z, which is going to be 8 times xyz, right? Since we don't want to deal with 3 variables, we want to be able to deal with only 2 variables. What we can do is we can take this expression and plug this guy into z here, right? So that the v is in terms of only x and y. So you have 8 times x, y, then z is square root of r squared minus x squared minus y squared, right? So we got that. All right, so in order to find the maximum volume, we're going to try to find a critical point. So we're going to take the partial derivative of the volume with respect to x, right? So in this case, with respect to x, so 8y is just going to be a number. So I'm going to put 8y out here. All right, then we take the derivative of x. So derivative of x would be 1 times square root of r squared minus x squared minus y squared plus x times the derivative of this guy. So it's going to be 1/2. So it's going to be 2 is going to be on the bottom. And subtract 1 from the power, so 1/2 power, so negative 1/2 power. So it's going to be square root is going to be on the bottom. So r squared minus x squared minus y squared, all right? Then multiply by derivative of inside with respect to x, partial derivative. So it's going to be negative 2x, all right? So we can cancel. There's 2 on top here and 2 on the bottom. All right, then we can, I guess we can find a common denominator. So you have 8y is sitting in front. And if you take the common denominator, you're going to get the square root of r squared minus x squared minus y squared. And then you're going to have, r squared. All right, so here's a negative x squared, and here's a negative x squared, so it's negative 2x squared minus y squared. All right, so we're going to set this guy equal to 0. All right, so obviously we want to maximize this volume. We're not looking for x, y, z being equal to 0, so that would be a very, very small, or there's no volume. So y is not going to be 0. So what we can do is we can set this guy equal to 0. So you have r squared. Actually, I'm going to write it as this. R squared is equal to, and I'm going to put those two terms on the other side, becomes 2x squared plus y squared, right? And then we can do the same thing, partial derivative of the volume with respect to y, right? But you notice that this equation right here is symmetric in x and y. So if you take the partial with respect to y, it's going to be exactly the same, except that the x and y's are switched. So you're going to have 8x, and then you're going to have square root of r squared minus x squared minus y squared. Here you have r squared minus and x squared minus 2y squared. Right? If you set that equal to 0, you're going to get the r squared is equal to x squared plus 2y squared. All right, so we got that. Then what we can do is this. I'm going to do a subtraction. So if you do a subtraction here, so that we can cancel r squared minus r squared is 0. Then you have 2x squared minus x squared would be x squared. Y squared minus 2y squared is negative y squared. So we can factor this guy out. So x minus y and x plus y, right? So looks like we know that x is going to be, or y is going to be equal to either x or negative x, right? But in this case, x, y, z is sitting in the first octant. So x is positive, y is positive, z is positive. So we don't have to worry about the y equals negative x. It's going to be y equals positive x. So y and x are equal to each other, right? So if you plug this guy back in here, we know that the r squared is equal to, right? You're going to have 2x squared plus x squared. So it's going to be 3x squared, right? And this is going to give you, right, divide by 3. So r squared divided by 3 is equal to x squared. Then we take the square root. So it's going to be, so x is going to be square root of r squared is r. Square root of 3 is square root of 3. And I'm not going to put plus or minus, since we assume x to be a positive quantity. All right, and then this is same as a y, so y is going to have exactly the same value, right? How about the z value? Z value is going to be square root of, right, r squared, and x is going to be all over square root of 3, so it's minus r squared over 3. And y is the same value, so r squared over 3. So you're going to get the square root of r squared over 3 again. So which is going to be r over square root of 3. All right. So the volume, maximum volume is going to be, oh, actually we didn't really have to find a z, but here, volume, so maximum volume is going to be, you're going to have to plug in, right, x equals r over square root of 3, and y is equal to r over square root of 3, right? So which is going to be, right, 8 times, right? X is going to be R over square root of 3. And Y is R over square root of 3. And actually Z is going to be R over square root of 3. Right? So which is, right, 8R cubed over 3 square root of 3. Right? So let's type it in. Right? So maximum volume is going to be 8R cubed over 3 square root of 3. Right? So let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.